is Associate Technical Services and Development Specialist at Dow. With a total work experience of more than 27 years, he has worked at Bombay Paints for 12 years, Advanced Paints for 3.5 years, and has been with Dow for 12 years till date. His areas of expertise include high-performance marine coating, water-based general industrial coating, water-based road marking, floor coating, water-based wood coating, water-based epoxy, amongst others. And Mr. Sudipto Bagchi, Key Account Manager at Dow. He has work experience of more than 17 years, previously worked with prestigious organizations such as Hindustan Unilever Limited and BASF, where he spent 2 years and 10 years respectively. His experience spans various industries such as architectural coatings, construction chemicals, technical textiles, and non-woven printing ink, soaps, and detergents. We are glad to be having our esteemed speakers with us, Mr. Bernard Fernandes and Mr. Sudipto Bagchi. Please.
Do you have this mic? Then it will be good. Okay, hello. Good evening, everyone. And as we move into the fag end of our presentation, I would like to thank IPCA and congratulate them for the tremendous turnaround that had been there for the last 1.5 days' time. And all the present audience, we are there, which are waiting patiently for the last presentation of the day. So I will start with our topic, which is the next generation of Hase rheology modifiers. And trust me, we are uncapping these 2 new products for the first time. This is our first presentation in India for the 2 products which we will be showcasing in IPCA. So from the last 1.5 days, we were hearing that innovation and differentiation plays a very major role in the SME or SMT sectors. So we also feel that the innovation or differentiation should be relevant to the market. So these are the 2 products which are very much relevant to the SMT sector, and these are all for the high PVC application. So I feel this will be something interest to the audience which is currently present here. So without much wasting time, I will come to the next slide. These 2 products, my colleague Bernard will take you through. But before that, I will talk a bit of Dow and the sustainability which is going on in Dow, which is very key buzzword today in Dow. Okay, so this is the flow of the presentation. I will talk first about Dow, then about Dow coatings material, which is we call it as ECM, the business from which I belong to, and then bit of sustainability, then Bernard will take over. So about Dow, Dow is a huge organization, as everyone knows. It's having 104 manufacturing sites in 31 countries, serving worldwide customers. And our ambition is to be the most sustainable, innovative, customer-centric, inclusive, sustainable material science company with the purpose to deliver sustainable future for the world through our material science expertise and collaboration with our partners. Our goal is value growth and best-in-class performance to all the stakeholders and partners. And our core values lies with integrity, respect for people, and protecting our planet. So as India is celebrating 75 years of independence, Dow is celebrating 125 years, and which I feel is very few companies who has been sustained this long and come to this stage. And the Mool mantra for this 125 years of Dow had been innovation. The first and foremost thing is innovation. Second is the culture within the organization as well as with the stakeholders. And third had been the partnership with all our customers with a problem-solving attitude and mindset. About Dow Coatings Material, about the business from which I belong to, we have 27 plants worldwide in 39 countries, which includes plants, warehouses, offices. We have the largest portfolio of coatings of raw materials and greatest breadth of technologies. We are the #1 in acrylic binders, #1 in waterborne additive portfolio. We have the largest investment in R&D, and our commitment towards R&D, we have a backward integration, world-class exposure testing, accelerated growth in emerging geographies. And these are the Dow acrylic emulsion network worldwide, which is 27. And in India, we have 2 sites. Sorry. So in India, we have 2 sites. One is Taloja and the Chennai. And we have a new site coming up in Saudi Arabia. In Saudi Arabia, this is a new plant which is coming up. So this is about all Dow network. This slide talks about the history of 70 years of expertise that Dow Coatings Material brings to the table in terms of acrylic binders, various different technologies in terms of bimodal particle, bimodal binder, multi-lobe binder, Heuer technology and Hase technology, and different other technologies. I won't go into the details of all the technologies, but Dow had been a pioneer in last more than a half decade globally. So this is the portfolio, or I would say this is the not the product portfolio, but the industry portfolio. So we have presence in architectural coatings, which is predominantly the binders, which is the interiors and exteriors, and mainly masonry and wood surfaces. Then we have a portfolio of additive, which consists of rheology modifiers, dispersants, and surfactants. We have a portfolio of industrial coatings, mainly water-based industrial, in terms of road marking, wood, liquid applied sound dampening, which is predominantly used in automotive, metal, can coating, and also the newest inclusion in this field had been the paper coating, which is a barrier paper coat, which is used as a replacement of LLDP or HDP kind of substrates. I will skip this slide because it's pretty much similar to compared to what it was presented in the last slide. So I will talk a bit about sustainability, which is very key, and many of our previous speakers has also been highlighting this topic. So the major 3 pillars on within Dow for sustainability had been the climate change, to address the reasons of climate change and what Dow can do in order to prevent the climate change and reduce the emission of greenhouse gases. Circular economy, to reduce the wastage coming out of the processes, and improving the health and safety of the products that we deliver to our customers. So this is the portfolio. So I will not go through the left-hand side. Left-hand side talks about the industrial part, and the right-hand side talks about the architectural part. So I will talk about the architectural part, which is, I guess, more relevant for the audience present here. So from architectural side, we have a FORMASHIELD technology. FORMASHIELD technology is basically something which is used to improve the interior air quality, and it scavenges the formaldehyde which is emitted from all the carpets and the interior wooden substrates coming out from the interior category. It scavenges all of them and thereby improves the interior air quality, something Dow strives for sustainability. Second point is the ROPAQUE and the EVOQUE technology, which is the replacement of titanium. Titanium, as we all know, is a very energy intensive industry, and these are the products which can replace titanium, thereby indirectly it can help in sustainability by reducing the carbon dioxide emission. Last but not the least, on architectural, you have this bio-based binders which has been the recent launches of Dow in last 1 or 2 years. Monomers which are coming out of renewable resources rather than from conventional binders. So these are the few innovations, and in the recent last couple of years which has come up, FORMASHIELD and bio-based binders. ROPAQUE is a pretty old technology. So this is something comes out of sustainability. Now additives, my colleague Bernard will take you through the 2 additive portfolio which is we have started launching from this forum.
Thanks, Sudipto. So today I will be introducing the 2 new products from the Hase category. So these are the new addition to the Hase family. So those are recommended for the high PVC paint. That's basically you start from the 75 PVC and above. So before going ahead, what is the role of the thickener? As in this slide, we can see the key attributes, right? But before that, we need to have a right selection of the thickener, so that only we can bring out a good paint in a can. So first of all, I would like to highlight some of the key attributes. It should be a stable product. So it should also have a consistent flow with good chemical resistance, no sagging, no settling, and after that, it should look good after it has been applied on the wall. So no air avoids or something should be left behind, or no sagging should be left behind. So you can see the red curve over here. So you can see the transformation of the paint from the can to the wall. So it should have a good flow, and in the between you can see a curve getting a flatten. So we can see at this area we can say that the paint is applied very uniformly. So when we apply the paint on the wall, it gets uniformly applied. So these are when we start from the beginning, it is a low shear, and when you take it to the tool or the application tool, the brush or the roller, it is called as a mid shear, and when it is transferred to the wall, it is called a high shear. There, when we apply the final coat, it should be applied in a very uniform manner. So we have a good relation between the viscosity and the shear, right? So as the shear increases, the viscosity lower downs. So at a certain point, it should have a good flow. So that will give a good uniform application. So it is similar to the example we need to take of a good athlete. So you can run in a marathon, which is a short distance, medium distance, and a long distance. At a 42 kilometer also, we need to perform with the similar physical strength the runner has to run into that way. So that is an example that this curve is going in that a similar way. It performed right from the beginning to the end when it comes to the paint comes to the wall. So few other, I could say the highlighted one, those are the black, those are the existing products which are going in the low share, the mid share, and we didn't have a product in the high share. So there was a gap that we were lying or having in the gap. So in that area, we used to promote a hair thickener. That was not a cost-effective solution for the SMEs. So we have come up with a new product that is called ACRYSOL RM-7. So that will fill those gaps, and it can give a very good uniform film. So the new products which have been highlighted in red, that is a new PRIMAL HT-700. So that is basically a low shear product, and we are promoting for this in the putty or the high texture. And the ACRYSOL RM-7 is for the liquid paint. So as we've seen that whatever the key attribute, what a good rheology modifiers should have, so we can see the RM7 gives the same key attributes over here. So it can give a high build film thickness, controls patterning, controls sagging, and the reduction of the HEC part. So there is a cost reduction also, but main part is we are here to show the performance of this thickener. So it is a 30% solid and a pH around 3. So this is the guideline formulation. So we have been in the left, to my left, you can see it is made completely on the HEC 0.7, and on that side we can see that it has been replaced by ACRYSOL RM-7. So the solids I have taken we have tried to replace the 0.3% with 1% of thickener as it is a 30% solid. So there is a cost saving, as we have taken a general number as a price of 800 of the HEC, and $2, that is almost 160 we are taking. And we can see the cost saving by 80 paise. So it might be a different, I could say, number for every manufacturer, because the cost will be different of HEC to each and every manufacturer. So here we can see the difference. This is the coating we have applied by the wire bar coater. So with the paint we made with the complete HEC and with the mixture of the HEC plus the Hase thickener, so we can see the performance. So we can see the uniformity on the that side. So here we can see the marks of the bar coater, but we can see the less of, you can identify, but there is a less of markings over there. So we have covered here the profile in each viscosity profile in each low shear as well mid shear and the high shear. So as per the curve what I have shown in the last slides, so here we can see in HEC at the lower shear we have a higher viscosity, but as we go to the 60 RPM, so the curve of HEC and the RM7 meets over there. So where we can say yes, it performs at a higher shear. Even in the KU builders, we can see the viscosity is also matching. So we are trying to bring a thickener that can really not hinder the performance in the viscosity or even in the application or in the performance wise. So even we have checked the viscosity in the high shear, that is IPCA viscosity, so it's hardly where we can see the difference over here. And even the reduction strength, we don't find any problem, so it is not affecting any color acceptance or also on the LAB values. So moving ahead to the new other thickener that is for the putty, that is PRIMAL HT-700. So primarily we have a primal for our emulsion as a name, but it is a different shade because it is made in Brazil somewhere, so they have given a name of this primal as an to this Hase thickener. So basically, when you see a picture, you can see a good gel structure over there. And basically, the main, I could say the benefit of that, it gives a smooth, uniform film, or it can have a good restructuring property. So when we put on the wall, it will not sag. So these are the key properties of the PRIMAL HT-700. So here we can see the difference, market sample made out of CMC or some other cellulosic thickener. And this is the entire based putty made out of PRIMAL HT-700. That is only 0.65 we added into this formulation, and we can see the difference. So it is not getting sagged, it is getting restructured as we remove the shear. So again, here is the benefit of the water resistant. When we apply a putty on a damp surface, there is a chance of getting the water entrapped into that, and it will bring a problem to the surface. When we apply a primer, on top of it we apply a coating with a finish paint. So there will be an intercoat adhesion problem when the water is coming onto the upper surface. So that is the difference between this, the putty made out of 700. When we dip this in water, we apply a putty on a panel, and even the market sample, and after 16 hours we dip the panel into the water, and we can see the marks over here. So we can see the loosening of the putty when it is kept in the water for almost 2-3 hours. So that's I could say key attributes over here, so that it won't absorb more water over here. So we have done with the presentation. Any questions? Hope you like this, our products, and you will really use those products for your product manufacturing.
Thank you very much, Mr. Bernard Fernandes and Mr. Sudipto Bagchi for the wonderful presentation. I request our President IPCA, Mr. Sagar Goyal, to please present a memento of our great appreciation for the esteemed